Hello everybody, today we're going to continue with our unit on the quadratic relations. Today we're doing a topic that should be familiar to most people, which would be the quadratic formula and the discriminant. Just note that you won't actually have to memorize the quadratic formula, just know why and when we would use it and kind of how to use it. We'll go through a number of examples today that highlight that, so it should be no problem. Okay, this first little bit here tells us to consider the quadratic equation 2x squared plus 24x plus 5. Okay, if I asked you to solve it, which means the x-intercepts of the solutions, we can't do those things by isolating. So in the last lesson we were isolating, but here there's an x squared and there's an x term. When we have more than one variable involved, we can't simply isolate. The next step we would look at is factoring, and things we've done multiple times before. We can't factor in this instance because there's no two numbers that multiply to 10 and add to 24 if you were to set up your t-chart on the side, because a times c, 2 times 5 is 10, and b is 24. No two values will multiply to 10 and add to 24. In these situations, when it's not possible, you need to use the quadratic formula. So a reminder, that this is the quadratic formula here. You've seen it before. We use it when we are given quadratics in standard form only. Okay, so x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Just note that this portion right here, the b squared minus 4ac, is what we call the discriminant, and it tells us unique features about our quadratic. And we'll get into that a little bit after our first few examples. But the best way to do this is just jump right in. So, solve the following by using quadratic formulas, remembering that this word solve, when we're asked to solve a quadratic, we're actually asked to determine the solutions, the zeros, or the x-intercepts. In this equation here, in problem A, all of our variables and constants are already on one side of our equal sign, and it's set equal to 0, so we don't have to do any rearranging. I would recommend that we do, in fact, write down our A, our B, and our C values. Okay, just before you get going, that way you have an understanding of where these are in your equation. Well, our A value is the coefficient in front of our x squared term. There's no coefficient, so you can assume A is 1. Our B is our coefficient in front of our x term. Here that's positive 5. And our c is our constant, or our value at the end of our equation, and it is negative 12. Okay, you want to write out the quadratic formula. Okay, well, without looking, negative b plus or minus the square root of b squared minus 4ac divided by 2a. One of the bigger formulas you work with in high school math. Okay, well, let's plug in our values. This would be 5. Because that's our b value. Again, 5 minus 4 times 1 times negative 12 divided by 2 times 1. Okay, if you simplify this, and I'm going to do it a little bit in steps, this can become negative 5 out front. Everything under our square root sign, that's 25 is 5 squared. 4 times 1 times negative 12 is 48, and if you are subtracting negative 48, you are adding 48, and here we have 2. Okay, if I take this a step further and simplify a little bit further, all I'm going to do is collect my like terms under the square root sign. I'm left with 73. Okay, and this is important because our next step, we're going to have kind of two branches. Our first one, solving for our first value of x, would be negative 5 plus the square root of 73 divided by 2, because as you can see we have plus and minus. There's our plus, and our second value of x is negative 5 subtract 73 divided by 2. Okay, if we continue and we actually solve this, so negative 5, take the square root of 73 and divide that by 2, you're going to get positive 1.77. if you do this, negative 5 subtract the square root of 73 divided by 2, you're going to get negative 6.77, and therefore your answers are 1.77 and negative 6.77. Okay, let's go on to the second example, which is just slightly different than the first one. Not everything is arranged properly here. We need to bring everything to one side of the equal sign and set our equation equal to 0. That means that this 15 needs to be brought over. Okay, so this is going to become 3x squared minus 4x plus 5 minus 15 equals 0. And we can collect our two like terms here, which leaves us with negative 10. And now we have our quadratic equation simplified in standard form. Again, let's identify our A, our B, and our C value. Okay, well, A here is 3, B is negative 4, and C is negative 10. I'm going to jump right in and substitute those values into the quadratic formula. So, negative 4. Okay, here negative 4 again. 4 times A, which is 3, times C, all divided by 2 times A. Okay, well, this negative 4 out front is going to simplify simply to positive 4. Okay, and under the square root sign, you're going to get negative 4 squared, which is 16. 4 times 3 times negative 10 is 120. You add those together to get the square root of 136. And 2 times 3 is 6. Again, at this point, you're going to branch off into solving for two separate values of x. First one would be 4 plus the square root of 136 divided by 6. The second one would be 4 subtract the square root of 136 divided by 6. Okay, well, our first value of x, if you solve that out, x1 is going to be equal to 2.61, and x2 is going to be equal to negative 1.28. And there you have used the quadratic formula. The only difference in this problem was we had a little bit of rearranging to do in our initial equation. Okay, let's continuing here. Going to go through the next page is kind of just more information without examples, so you can either listen in or move on to problems that involve the discriminant. Each of the above examples has two solutions. So we had x1 and x2, and they are both unique, meaning that they were different values. Recall a solution in another word for quadratic zeros or x-intercepts. We've gone over that. This is not always the case, however. Quadratics can have two solutions, as we just saw, but they can also have one or no solutions at all. If you look at the graphs below, these highlight kind of examples where we see them. So this first example here is another example where we have two solutions. Two solutions meaning we have 2 points that cross our x-intercept. We have two zeros, whatever you want to call them. Another situation, and we see that here, would be the fact that we have only one. If we only have one solution, that one solution or that one x-intercept is also the quadratic's vertex every time. So if you have a situation where there's a problem and it says what is the vertex of this quadratic that has one solution, you just need to solve for the x-intercept, which is also going to be your vertex. And you can also have another option, which would be essentially if you had no solutions like this quadratic here. You could also have something below the x-axis that opens down. As long as you see no crossing of the x-axis, then you have no solution. So there's three unique scenarios. Part of the quadratic formula, which I highlighted right at the start, is known as the discriminant. So the discriminant is b squared minus 4ac, and it's that portion found under the square root sign of our quadratic. We can use just this part to determine how many solutions a quadratic has, as opposed to using the entire quadratic formula. It saves us some time and some steps, and you're less likely to make an error. So to determine whether a quadratic has two, one, or no solutions, look at the values under the square root sign of the quadratic. This is the discriminant. If our discriminant. Okay, so I'm looking at these things down here. If our discriminant is greater than 0, okay, that's what those signs mean, then there are two solutions. So if you solve b squared minus 4ac and you got, let's say, positive 40, that's greater than 0, you can conclude that there are going to be two solutions. If the discriminant is equal to 0, so you solve b squared minus 4ac and the solution is 0, then there's only one solution, which would be the vertex of your quadratic. And the last one, if b squared minus 4ac, the discriminant is less than 0, there are no solutions. So there's three different scenarios we can look at, and we'll go through examples of how I want you kind of to answer these questions. So let's get into that. Okay, so determine the number of solutions that each of the following quadratics had by using only the discriminant. So I don't want you to use the entire quadratic formula, although it will give you the same answers. It will give you the actual values. I just want to know how many solutions. So write the discriminant out, b squared minus 4ac, and in this equation, a is 3, b is negative 6, and c is negative 12. So plug in those values as you see. Negative 6 squared times 4 times 3 times negative 12. Okay, well, negative 6 squared, that's 36. 4 times 3 times negative 12 is negative 144. If we're subtracting negative 144, then we're actually adding it. And our value here is 180. Well, that value is positive and it's greater than 0. Therefore, this we have two solutions. Okay, for our next problem here, same thing. Start with the discriminant. List your variables. A is 1, B is 2, and C is also 1. Okay, well, solve this out again. This is equal to 0. Okay, in this case, therefore, this is one solution, and that solution again would be the vertex. And the last one, I'm assuming you can figure out the trend. We're going to kind of represent all three types of examples. The discriminant, our values here are A is 1, B is negative 4, and C is 5. Plug those values in as I'm doing here. Negative 4 squared is 16. 4 times 1 times 5, that's 20. 16 minus 20 gives you negative 4. Therefore, we have no solutions. That quadratic would not cross the x-axis because that value is less than 0. Now, you might have problems where you are not given standard form, but in fact you're given vertex form. So, what happens if the quadratic is in vertex form? First thing you want to do is identify your a value. Always look at the a value in the equation, and that's why I've been highlighting that as we've gone through these examples. Next, you want to identify the vertex. Remembering the vertex is h and k as they appear in vertex form of a quadratic. And then draw a rough sketch, meaning use the direction of opening and use the vertex to identify which quadrant that would be in. Okay, so for this example, determine the number of zeros for f of x is equal to negative 2 x plus 3 squared minus 8. So we know this is vertex form. Okay, our a value here is negative 2. What does that mean? Well, it opens down. We've looked at that a number of times in this unit. Okay, our vertex here is our h and our k values. Our h and our k values are, is 3 and negative 8. Remembering that h value, their x value of a vertex, is always opposite, so this becomes negative 3 and negative 8 is our vertex. If I were to draw a rough sketch, so I have my 4-quadrant grid here. Okay, well, here is x -3 and y is -8. -3 for x would be right here. -8 for y would be somewhere down here. That would be where my vertex is. This a value tells me it opens down, so it will look something like this. Might be thinner, wider, or whatever, but this is the only information I really need. This tells me that it's not going to cross the x-axis, and therefore this quadratic here would have no solutions. Okay, so those are the steps with vertex form. So now you could be able to determine how many solutions a quadratic has in both standard and vertex form. And now for more of a thinking problem, and you'll see questions like this in your textbook and maybe on assessments, where they have a missing value in your equation, which is k. Okay, so they're going to identify some unknown variable, and they're going to ask you this question: what values of k will 3x squared plus 8x plus k equals 0 have two solutions or one solution? So it's saying, what possibilities could you plug into that value of k to make this quadratic have two solutions or one solution? Well, if I have two solutions, okay, if I want this quadratic to have two solutions, remember the discriminant b squared minus 4ac must be greater than 0. That's for two solutions. Well, if I want to write that out using values, I did this up top. This says the discriminant must be greater than 0. We'll plug in what you know. Okay. B we know is 8. So I'm going to plug that in, 8 squared. Okay, A is 3, and C right now we've represented as K. Let's simplify this a little bit. 8 squared, that's 64. And then if we have 4 times 3, that's 12, times K, that's 12K. At this point, you're going to want to treat this greater than symbol as an equal sign, and I want you to isolate and solve for k. Well, that means bring this over. This brings 64 equals negative 12k. Divide by negative 12, divide by negative 12. And if I reduce that fraction, 64 over negative 12, I get negative 16 over 3. Therefore, I can say k must be greater than negative 16 over 3 to have two solutions. So any value that is greater than negative 16 over 3 will work plugging into this equation if I want this quadratic to have two solutions. Okay? Same thing here. The next part of this was one solution. Well, one solution, if that's true, the discriminant must be equal to 0. So I'm going to set this up similar to what I just did with two solutions. 0 equals b squared minus 4ac. Okay, well, I'm going to plug in what I know. 8 minus 4 times 3 times k. Okay, well, same thing, 64 minus 12k. We're going to isolate for k just like we did. So this becomes 64 and sorry, this should be negative 64 if I bring it over. Divided by negative 12, divided by negative 12, k is equal to 16 over 3 when you reduce that. So to have k must be equal to 16 over 3 to have one solution. So the only way you can get one solution is if that k value is 16 over 3, or if you made that if that's kind of challenging for you to look at, 16 over 3 is the same as saying 5.33 repeat as a decimal. And just to correct a mistake over here, we should have made that 64 also negative, and therefore our answer here would be positive and not negative. So this would actually be k must be greater than 16 over 3. Go through that at your own pace, and I hope that helps.